cyclic quadrilaterals. Cyclic quadrilaterals. Now, a quadrilateral is simply a shape with four sides. Okay? So any shape with four sides is a quadrilateral. So what happens when it becomes cyclic, when it becomes a cyclic quadrilateral? So a cyclic quad is a four-sided shape whose vertices or corners all touch or all sit on the circumference. So for something to qualify as a cyclic quad, it must have four sides and all four corners sitting on the circumference. So let's look at these two illustrations. Okay, here's the first shape. Then here's our second shape. If we look at the first shape here, that corner, that corner, that corner, and the last corner, all of them sit on the circumference. So this qualifies to be a cyclic quad. For this quad, three corners are sitting on the circumference, but one is not. So this one is not a cyclic quad. So we need to understand that we're going to look at two theorems in this video, and the theorems apply to cyclic quadrilaterals. So before you apply them, you need to make sure that what you're looking at is a cyclic quadrilateral. So how do you know something is a cyclic quadrilateral? Four-sided shape, and all four corners of the shape sit on the circumference. So let's proceed to the theorems. So theorem 1 of cyclic quads. Theorem 1 of cyclic quads. Opposite angles of a cyclic quad are supplementary. So opposite angles of a cyclic quad are supplementary. And supplementary means they add up to 180 degrees. So two opposite angles of a cyclic quad should add up to 180 degrees. So a simple illustration is, I've got my circle there. I've got my cyclic quad. Cyclic quad. If you look at your cyclic quad, this angle is opposite that angle, right? So if I call this angle x and that one y, x plus y should give me 180 degrees. So this should always, so if I know this is 110, this must be 70, because 110 plus 70 add up to 180. Now these two are also supplementary, and the same theorem applies to those two. So that's simply what it is. It's opposite angles are supplementary, right? We're talking about the interior angles of a cyclic quad. Now let's proceed to theorem 2 of cyclic quad. Again, there's only two theorems. So there's theorem 2 of cyclic quads. Exterior angle is equal to interior opposite. So that's what happens with cyclic quads. An exterior angle of a cyclic quad is equal to the interior opposite angle, right? Exterior is equal to interior opposite angle, right? Let's see what that's going to look like. If this is our circle, not the best circles I can draw, and then our cyclic quad is like this. If we produce one of the cyclic quads, in other words, extend like that, we'll get an exterior angle. This angle that's on the outside there is the exterior angle of a cyclic quad. Now, if you look at the corner where that exterior angle is, this is the corner, right? This is the corner where the exterior angle is. This is opposite that one, okay? So the interior opposite will be this one. So this is interior and this is opposite. These two angles will be equal, right? So if this is 40 degrees, that will be 40 degrees. If this is 90 degrees, that will be 90 degrees. If this is 110, that will be 110. So whatever the interior opposite is, the exterior angle is also. So those are the only two theorems for cyclic quads. And you can try some questions by applying the simple logic and reasoning around these two.